with all of this. So continuing on, have you heard of a Venn diagram? Yes. Okay. So normally you've probably seen Venn diagrams like this, right? Where there's overlap, but they're both separate as well. Today they're going to ask you to do Venn diagrams, but you're not going to do it like this. You're going to do it like this. Okay. So one will be totally enclosed in the other. Kind of looks like an egg with an egg yolk a little bit, maybe. I'm going to give you a statement and see if you could set this up as a Venn diagram. So if I said, if an animal is a robin, then it is a bird. Okay, so think for me, what part of that would be in the small circle, and what part would be the big circle? Reagan.
It is the bird in the small circle, and the robin would be in the big circle.
No, the other way around. Does that make sense? If we're talking like a big umbrella something, the big umbrella something is birds in general, right? So we would put birds here. One type of bird would be a robin. So if you think of it, we could essentially make another set of Venn diagram stuff. We could call this eagles, and we could call this storks. There's all different types of birds, right? A robin is one of those. So the robin has to be the smaller thing. The bird category is the overarching category. Does that make sense? Okay, so when they ask you to do, don't worry about those. When they ask you to do a Venn diagram, this is what your Venn diagram will look like, not the two overlapping, but some not overlapping. It's not that kind of Venn diagram, okay? Okay, they will also ask you to write a conditional from just a statement. So let's say we have a statement like this. Vertical angles share a vertex. Is that an if-then statement?
No.
No. Your job is to make it an if-then statement. Anyone think they can do that from this? PJ.
Vertical angles don't share a vertex. Okay.
No, you want to make it if.
No. If an angle is vertical, if two angles are vertical,
Yes.
they share a vertex.
Yes.
Then they share a
Okay,
vertex.
so there's always kind of something that has to get added to it when you make it an if-then, right? You need to figure out what you're talking about. So if two angles are vertical angles, okay, then they share a vertex. Okay. Can you tell me, like if I said dolphins are mammals, could you make that an if-then statement?
I can.
You already got to, so let's see if somebody else can. Dolphins are mammals. How can you make that an if-then? Yeah, Ryan.
If the dolphin is an animal, then if an animal is a dolphin.
There you go. Yes. If an animal is a dolphin, then it's a mammal. Okay, so you're just turning it into an if-then from whatever statement is being made. Okay? Okay, then there is going to be talk of a negation. And maybe you know what a negation is, maybe you don't, but you can kind of see it in the word negate, negative. A negation is just the opposite of whatever statement is already being made. So, for instance, if I say the sky is blue, the negation of that would be the sky is not blue, okay? If I say the sun is not out, the negation would be the sun is out. So usually a negation is just adding a not or taking out a not. Sometimes that's not the case, but I would say 90% of the time it's just put a not in, take a not out. Okay, one of those two. Okay, then here's kind of the big setup for this lesson. You will have a conditional statement. What is a conditional? It's an if-then. Okay, so your conditional statement, I'm going to give these to you in terms of letters instead of a big long sentence, okay? The conditional statement is said if P, then Q. So we're saying if P, then Q when we see this. Okay, you say that if P, then Q. Okay, so if that's my conditional, can you tell me what the converse of that would be? If Q, then P. I'm just writing the quotes part just so you know what this is saying. If you know what that's saying, don't write all of that. You don't need it. I just want you to know how I'm saying it. Okay, so that's the converse. Those are the two they talked about in the video, but there's two that they didn't talk about in the video that are in this lesson. And those are called the inverse, which an inverse is going back to your original conditional and negating both parts of it. So now instead of if P, then Q, it's if not P, then not Q, okay? So like I said, if not P, it's a tilde. It's on a keyboard, it's that top left button on the keyboard. If not P, then not Q. Okay, so that's how you show a negation, is with that little tilde mark. And then the last one is called a contrapositive. Anyone want to guess what the contrapositive is? You have all the information you need, pretty much. It is a negative.
It contradicts the positive.
I mean, in terms of P and Q, what would it be?
If not P, then Q.
Nope,
If P, then not Q.
nope. If not Q, then not P. Okay, so notice what happens. This, if P then Q, got negated for the inverse. The inverse then gets the converse of the inverse to get you the contrapositive. So the contrapositive is the converse of the inverse, if that makes sense. Okay? Here's what you need to know about these to just make your life easier. These two right here will always have the same truth value. So if the converse is true, the inverse will be true also. Okay? So the converse and inverse will either both be true or both be false. The conditional and the contrapositive, so these two, will also always have the same truth value. Okay? So that means if the conditional is true, the contrapositive is true. That means if the conditional is false, the contrapositive is false. Okay? So let's just think through what your options are here. If you have conditional, converse, inverse, and contrapositive, if my conditional is true and my converse is true, what's my inverse going to be?
It is going to be false.
No, true. Because it will have the same truth value as the converse, right?
Well, then the last
And the last one would also be true because these have to have the same truth value
It says
also.
not P, though,
Okay?
on the last one. Oh, they all say.
I'm just saying it true or false. I'm not saying negation or regular. Just is the statement true? And I'll show you this in a minute if this is not clicking. Okay, so what if the conditional's true, but the converse is false? Then what's the inverse going to be?
It's going to be true. It's going to be false.
It's going to be false, and the contrapositive is going to be true, right? So you could go true, false, false, true. Or what if both the first two are false? What are the next two?
True.
Both going to be false. Okay?
I'm confused.
I'll show you in a minute. I'm going to, just wait. I'm going to show you with an actual example, okay? If the conditional is false and the converse is true,
Bless you.
then it's going to be true, false for the remainder, okay? I'm going to show you an example right now.
Thank you.
All right. Let's say our conditional statement says if a figure is if a figure is a square, then it's a rectangle. Okay, that's my conditional statement. If a figure is a square, then it's a rectangle. Is that true?
That is incorrect. It's false.
That is true. If a figure's a square, right? Here's
Oh,
a
it
square.
has uneven sides.
It is a rectangle with 4 congruent sides. Okay, so that is true. The conditional is true. That means that right now, without even knowing what the contrapositive says, I know that the contrapositive is what? True or false?
True.
True, because they have to have the same truth value. Okay? All right, so if that's my conditional, what is my converse?
True.
We don't know the truth value yet. What would the converse say?
It would say if it's a rectangle, then it's a square.
Yes, if a figure is a rectangle, then it's a square. Okay, if a figure is a rectangle, then it's a square. Is that true? Is every rectangle a square? No, this is false. Okay, that means my counter example, you can just draw a picture rather than try to explain it in words. A counter example would be this, right? That is a rectangle, so the if part is true, but it's not a square. The then part is false. Okay, so that's a counterexample. Okay, now you should know the truth value of the rest of your statements. So let's just, before we even write them out, let's just talk real quick. What is the truth value of your inverse going to be? Is it true or false?
It is going to be false.
It is going to be false because it has to be the same as the converse. Okay, so we know it's going to be false, which means we know there's going to be a counterexample. What is the inverse going to say?
It's going to say if a figure is a square, then it's not a rectangle.
If a figure is not, you have to negate both parts, right?
If it's not a square, then it's not a rectangle.
If a figure is not a square, then it's not a rectangle. Okay, so your counterexample would be what?
If a figure is a square, then it's not. If it's not a square, then it's a rectangle.
No, the counterexample, not the next statement.
Oh.
So your counterexample could be the exact same thing, right? Could look like that.
Definitely way too hot here.
It is way too hot in here. I fully
We're
agree.
gonna take this class outside.
We can't.
You got any fans in here?
No, I wish. All right, contrapositive, true or false?
Right, heard it.
Contrapositive is true because the conditional was true, right? So conditional and contrapositive will always be the same. What's the statement? It's the converse of the inverse, right? So you take the one right before it and you flip them. So if a figure is not a rectangle, then it's not a square. Okay?
Okay.
That is what you're doing. If you can keep those 4 straight, you're in great shape. Okay? That's the other thing. It is a lot of writing.